Now see question number 9 from exercise 5.3. Prove by vector method that the angle subtended on semicircle is a right angle. Actually this type of theorem you already proved in class 10, but by using Cartesian form. Here we have to prove that by using vector form. In class 10 you prove the theorem, the angle subtended by a diameter in a semicircle is a right angle. So here we consider a circle with a diameter AB having center at C, and consider a point P other than point A and B on the circle. Then we have to show here this angle APB is a right angle. So first we write here in proof. Let AB be the diameter of circle with center C, and let P be any point on circle other than A and B. A and B. Why other than A and B? If we consider this point P at A, then we get straight line. If we consider this point P at P, then again we get straight line. That means angle get 180 degree. So we consider a point on this circle other than AB. So we have to show here, then angle APB subtend in a semicircle. Now we have to show that this angle APB is 90 degree, because we have to show that the angle subtended on semicircle is a right angle. So for showing the two lines or two vectors are perpendicular to each other, we show their dot product is 0. So we have to show here this side AP and this side PB of triangle APB are perpendicular to each other at point B. So we find here first vector AP. Therefore vector AP is equals to, now here we consider vector AC as A bar, vector BC as minus A bar, and vector PC as R bar. That means we consider position vector of A with respect to C as A bar, position vector of B with respect to C as minus A bar, and position vector of point P with respect to C as R bar. So we write here AP bar equals to AC bar plus CP bar, that is equal to AC bar is A bar, CP bar is R bar. So we write R bar plus A bar as equation number 1. Then we consider vector BP. So we write here, therefore vector BP is equal to, we write here B to C, C to P. So write vector BC plus vector CP. Now we have the value of vector CB. So from that we write here vector BC as minus A bar. So we write minus A bar plus CP is R bar. So we interchange it, R bar minus A bar. This equation number 2. That means we have to write first the position vector of A is A bar, position vector of B is minus A bar, position vector of point P is R bar. Or directly you can write vector AC equals to A bar, vector BC equals to minus A bar, vector CP equals to R bar. So we write here vector AC as A bar, AC as A bar equals to vector CB That means you can also write AC equals to CB equals to vector A and vector CP is equals to R bar. Now vector AC and vector CP both are the radius of this circle, so you can write magnitude of vector A is equals to magnitude of vector R. Then you can write these steps. Now we have to show this vector AP perpendicular to vector BP. Therefore vector AP dot vector BP is equals to, now substitute the value of vector AP as R bar plus A bar. Now substitute the value of vector BP as R bar minus A bar. So after multiplying it, R bar, so we write R bar dot R bar minus R bar dot A bar plus A bar dot R bar minus A bar dot A bar. Now just we multiply these two brackets and taking the dot product between them. So R bar dot R bar can be written as magnitude of R bar square. Dot product is commutative, so we write this R bar dot A bar as A bar dot R bar. So this term cancel with this third term. So we write here directly minus A bar dot A bar, since R bar dot A bar is equal to A bar dot R bar. Now magnitude of R, magnitude of A is same because both the vectors are the radius, so their magnitude must be same. So from this we write this is equals to 0, or you can denote this as equation number A or Roman I. So you can write here from equation or Roman I. So this shows that this vector AP perpendicular to vector BP, that means this AP perpendicular to BP, so they make angle 90 degree at point P. Therefore vector AP perpendicular to vector BP, that means the angle subtended on a semicircle is a right angle. So in this way you can write the proof. Angle APB is a right angle. Now see question number 10. If a vector has a direction angle 45 degree and 60 degree, find the third direction angle. So in solution, if we consider this first angle as alpha, so we write alpha equals to 45, this angle as beta, so we write beta equals to 60 degree, and we have to find the third angle, which is gamma. So we know the theorem, if L, M, N are the direction cosine of a line, then L square plus M square plus N square equals to 1, or cos alpha or cos square alpha plus cos square beta plus cos square gamma equals to 1. So we substitute the value of cos alpha. So first we write this as cos alpha 8 square plus cos beta 8 square plus cos gamma 8 square is equal to 1. Now substitute the value of alpha as 45. So we write cos 45 8 square, here cos 60 8 square plus cos gamma 8 square is equal to 1. Now cos 45 is 1 by root 2. Cos 60 is 1 by 2. Cos gamma we have to find. Squaring the first term, second term and transferring to right hand side, we get in left hand side cos square gamma is equal to, or cos gamma 8 square is equal to 1 by root 2, 8 square is 1 by 2. So we transfer that 1 by 2 to right hand side, we get minus 1 by 2. Square of 1 by 2 is 4. Transfer that 1 by 4 to right hand side, we get minus 1 by 4. So make base same. So multiply and divide by first term by 4. Multiply and divide by second term by 2. So we get 2 by 4 minus 1 by 4. Now base is same. So write base 4. 4 minus 2 minus 1. So we get here 1 by 4. this is value of cos gamma its square. So taking square root on both sides, we get cos gamma equals to plus or minus 1 by 2. That means cos gamma is equals to 1 by 2 and cos gamma is equals to minus 1 by 2. So we write here cos pi by 3 is 1 by 2, which we already see. Cos 60 is 1 by 2. So we write here cos pi by 3 is equals to 1 by 2. Now we have to find cos of minus 1 by 2 value. So we write this as cos gamma is equals to cos, we write here minus sign, minus cos of pi by 3. So this minus pi by 3 can be written as cos of pi minus pi by 3, because cos pi minus theta is minus cos theta. So we find this value 3 pi minus pi, that is 2 pi by 3 cos 2 pi by 3. That means we get the value of alpha as gamma is equals to pi by 3 and 2 pi by 3. So in this way we can find the third direction angle. 11. If a line makes angles 90 degree, 135 degree, 45 degree with x, y, z axis respectively, then find its direction cosines. Here we have to find the direction cosines and direction angles are given. So in solution, if L, M, N are direction cosines, then we write here L equals to cos alpha, M is equals to cos beta, N is equals to cos gamma, where alpha, beta, gamma are the direction angles. Now here alpha is equals to 90 degree, beta is equals to 135 degree and gamma is equals to 45 degree. That means direction angles are given. From that we have to find its direction cosines. So we first find the L, that is cos alpha. So replace the value of alpha by 90 degree. So we get cos 90. Cos 90 is 0. That means L equals to 0. Then beta is equals to, M is equals to cos beta is equals to cos 135 degree. So we have to split up this in the form cos 180 minus 45 degree. So cos 180 minus 45, that is minus cos 45. So we get minus cos 45 is 1 by root 2. So we write here cos 45 is 1 by root 2. Then we have to find N. N is equals to cos gamma, that is equals to cos 45, and cos 45 is 1 by root 2 because gamma is 45 here. So we replace gamma by 45. Cos 45 is 1 by root 2. Therefore the direction cosine of line is, therefore the direction cosine of line is 0 minus 1 by root 2, 1 by root 2. So in this way we find direction cosine from direction angles. Now see question number 12. If a line has a direction ratios 4, minus 12, 18, then find its direction cosines. So in previous part we already see a relation between direction cosines and direction ratios. So we write here a relation between direction cosines and direction ratio first. If LMN, if N are direction cosine and ABC are direction ratio, then N is equals to plus or minus A upon under root A square plus B square plus C square. M is equals to plus or minus b upon under root a square plus b square plus c square. N is equal to plus or minus c upon under root a square plus b square plus c square. So here direction ratios are given, that means value of a, b, c are given. So we write here a equals to 4, b equals to minus 12, c is equals to 18. So this is given part, a equals to 4, b equals to minus 12, c equals to 18. So we first find the value of root a square plus b square plus c square. Therefore under root a square plus b square plus c square equals to, now value of a is 4, so we write 4 square. Value of b is minus 12, so we write 12 square. Value of c is 18, so we write 18 square. So first we square each term. Square of 4 is 16, square of 12 is 144, and square of 18 is 324. Now add this, we get 482, which is square of 22. So here we get square as addition as 484. So its square root is 22. So we first calculate the value of root a square plus b square plus c square. So from this we can find L, M, N easily. So substitute the value of a. Here a is 4. So we write here L equals to plus or minus 4 upon 22. That is plus or minus 2 by 11. We calculate the value of m. Now substitute the value of b as minus 12. So we write here minus plus 12 upon 22, which is equal to minus plus. Now when we divide by 2, we get here 6 by 11. Now see third, n equals to plus or minus c upon under root a square plus b square. Value of c is 18, so we write here plus or minus 18 upon root a square plus b square plus c square is 22. So we get here plus or minus 9 by 11. So the direction cosines are plus or minus 2 by 11, minus plus 6 by 11, then plus or minus 9 by 11. So in this way we find direction cosine when direction ratios are given by using the relation between direction cosines and direction ratios. Now see question number 13. The direction ratio of vector AB are minus 2 to 1. If coordinate of A are 4, 1, 5 and length of AB equals to 6 units, find B. So here we have to use concept. If A and B are 2 points, distance between these 2 points is D, and direction cosine of this vector AB is given or direction cosine is given. If direction ratios are given, then we can find from that direction ratio direction cosine of that line. So we can find if coordinate of point is A as x1, y1, z1 and coordinate of this point B as here x1 plus or minus LD, y1 plus or minus MD, z1 plus or minus LD. By using this formula, we can find the coordinate of other point which is at a distance d from that given point. So for that we first find L, M, N. Now for that we use again relation between direction cosines and direction ratio, which you already used for last question, that is for question number 12. If L and N are the direction cosine and ABC are direction ratios, then we know the relation for L, M, N. So we first calculate the value of root a square plus b square plus c square first. So here a is equals to minus 2, b is equals to 2 and c is equals to 1. So we find root a square plus b square plus c square. So minus 2 square is plus 4 2 square is plus 4, 1 square is 1, so we get square root of 9, which is equal to 3. So we write here L is equal to plus or minus, value of A is minus 2, so we write here minus plus 2 upon 3. Then plus or minus B, value of B is 2, so we write plus or minus 2 upon 3. Then value of C is 1, so we write here plus or minus 1 upon 3. So in this way we find L, M, N. Now we have to find the coordinate of point which is at a distance 6 unit from this point A, that is coordinate of point we have to find. So we write here the coordinate of the points which are at a distance of d units from the point x1, y1, z1 are given by x1 plus or minus nd, y1 plus or minus md, z1 plus or minus nd. Now we have value of d, length of AB equals to 6. So here d is equals to 6. We take L is equals to minus 2 by 3, M is equals to 2 by 3, N is equals to 1 by 3. Now substitute the values. We get coordinate of point B. So we write here x1 plus or minus LD is equal to x1 is 4 here. So we write 4 plus or minus L is minus 2 by 3 into D is 6. So calculate this value first. When we take a plus sign, we get here 4 plus in bracket minus 2 by 3 into 6 is equal to, so plus minus, so we cancel this 3 to the 6, 4 minus 4, 0. So first value we get 0. When we consider plus sign is positive. When sign is negative, we get 4 minus in bracket minus 2 by 3 into 6. So minus get plus. So we write here 4 plus 2, which is equal to 6 when sign is negative. So same way we find value of y1 plus or minus md, z1 plus or minus nd. Here we get minus plus 2 into 2, 4. So we get here 4 plus 4, 8. Now we have to find y1 plus or minus md. Y1 plus or minus md, which is equal to y1 is 1. So we write 1 plus or minus value of m is 2 by 3, and d is 6. So we write this as 1 plus or minus 2 into 2 is 4. So when we consider plus sign, we get 1 plus 4 equals to 5. When we consider minus sign, we get 1 minus 4 equals to minus 3. So this is value for y1. Then we have to find z1 plus or minus md equals to value of z1 is 5 here. So we write 5 plus or minus n is 1 by 3 into d, which is 6. So substitute the value of d as 6. So we get here 5 plus or minus 1 into 2. We write 5 plus or minus 2. When we consider plus sign, we get 5 plus 2, which is equal to 7. When we consider minus sign, we get 5 minus 2, which is equal to 3. Therefore, the coordinate of point B are. So we consider for positive sign only. So we get 0, 5, then 7. And for negative sign, we get here value as B. So we get 8, then minus 3, then 3. So in this way we can find the coordinate of a point which is at a distance of 6 units from the. Now last question of this exercise. Find the angle between the lines whose direction cosines lmn satisfy the equations 5n plus m plus 3n equals to 0 and 5nn minus 2nn plus 6lm equals to 0. That means we have to find the angle between the direction cosines, but here direction cosines are not given. A relation between the direction cosines is given, so we have to find the direction cosines from these two equations. So we denote this first equation 5m plus m plus 3n equals to 0 as equation number 1, and this equation 5m minus 2nl plus 6m equals to 0, and this is equation number 6. So we take value m from equation number 1 and that value we put in equation number 2. That means we reduce that m from these two equations. See here, put m is equal to, now we transfer this 5l to right hand side, so we get minus 5l. We transfer this 3l to right hand side, we get minus 3l. So we put m equals to minus 5l minus 3l in equation number 2. So we get here 5 in place of m, we write 5l minus 3l, this m as it is, minus twice nl as it is, plus 6l. Value of m is minus 5l minus 3l is equal to 0. Now multiply that 5l, so we get 5 5s are 25, that is minus 25 l into l, that is ln. Then multiply by 5l, so minus 5 3s are 15 l into l square, that is minus 15 l square. Then this minus twice nl as it is. Then multiply by 6l to this bracket, so we get here minus 6 5s are 30 l square. Then plus minus minus 6 3s are 18, ln is equal to 0. Now we can add the terms of ln. This ln is also ln, so we add up these two terms. Minus 2 minus 18 we get minus 20, minus 20 minus 25 we get minus 45 ln. Then this minus 15 l square minus 30 l square is equal to 0. So we can take minus sign common from this. So we write this l square at first position. So we write here minus 30 l square minus 45 ln minus 15 l square equal to 0. Now we take minus 15 common here. When we take minus 15 common, so we get here 2l square minus minus plus 3 ln minus minus plus l square is equal to 0. Now such types of problem we solve in pair of straight lines while separating the equations. So we observe the coefficient of l square, which is 2. Coefficient of n square is 1, so 2 into 1 is 2. So we have to split up that 2. So as to get their sum is 3. So we write here, therefore 2l square plus 3ln plus l square equal to 0. Therefore 2 into 1, coefficient of n square is 1, so 2 into 1 equal to 2. We have to factorize this 2. So as to get its sum is 3. So we take factor as 2 into 1. So we write this as 2l square plus 2ln plus 1 times ln. So directly we write ln plus n square equal to 0. Now we can take a 2l common from first two terms. So we write here 2l in bracket l plus n plus, here we take n common, so we write l plus n equals to 0. So taking again l plus n common from these two terms, so we write l plus n in bracket 2l plus n is equal to 0. Therefore l is equal to minus n, or we write 2l is equal to minus n. That means here l is equal to minus n by 2. Now we substitute this value of l in this equation. So we get the relation between L, M, N. Now consider here, if L equals to minus N, then M equals to, so we calculate M from this substitution. We can denote this as equation number 3rd. So if L equals to minus N, then M equals to, we substitute the value of L as minus N, so this minus 5L as it is, minus 3 into N, we replace this, we replace L by N, so we replace this L by minus N, then minus 3N, so we get here minus plus 5N minus 3N, which is equal to 2N. So when L equals to minus N, we get M is equal to twice N. Now see this term, M equals to 2N, so we find from this value of M in terms of N, so we write this L is equal to M by 2. Now here L equals to minus N, here we get N as M by 2, so from this we calculate minus M first, so we get minus M by 2. Now we write this as L is equal to minus N, and this minus N equals to minus M by 2. From this we write L equals to minus N, and after substituting that value in M, we get value of M in terms of N. So we write here, multiplying both sides by minus sign, we get minus N equals to minus M by 2. So this L equals to minus N, and this minus N equals to minus M by 2. So from this we write this as L by 1 is equals to N upon minus 1 is equals to M upon minus 2. So the direction ratios are 1, minus 1, minus 2. Similarly, when we substitute the value as L equals to minus N by 2, again we get the value of this M in terms of N. So from that we calculate the direction ratios. These are the first direction ratios. Now we have to find the second direction ratios. So we write this in proper order. L by 1, L after we require M. So we write L M by 2 minus 2 equals to M. M is M upon minus 1. You can multiply by minus sign also. So you can solve in this way also. L by minus 1 equals to M by plus 2 equals to N by plus 1. You get ratios as minus 1 plus 2 1 also. So don't confuse with that. You get the ratio 1 minus 2 minus 1 or minus 1 to 1. Now we find the value if 2L equals to or L equals to minus N by 2. So we write direction ratios of first line as A1 equals to minus 1, B1 equals to 2 and C1 equals to 1. Now we find the second direction ratios. Now here L equals to minus N by 2, or we have convenient to replace the value of N. So we write this as also N is equals to minus twice N. Now substitute N equals to minus twice N, or we can say if N equals to minus twice N from equation 3rd. What we write from equation 3rd here? M is equals to minus 5N minus 3 into N. So substitute the value of N as minus twice N. So we write M is equals to minus 5N minus minus plus 2 into 3 6N. So we get here 1N. That means M is equals to L. Now here M is equals to L. Here L equals to minus twice L. Now we can replace the value of L by M. So we get here L is equals to M is equals to. Now we can replace the value of M. Now first we write here M is equals to L. So from this we write L as, after transferring this minus 2 to left hand side, we get N upon minus 2. So we write L equals to M equals to N upon minus 2. Now we write this again as L by 1 is equal to M by 1 is equal to N upon minus 2. That means 1, 1, minus 2 are the direction ratios of second line. Therefore, A2 is equals to 1, B2 is equals to 1, C2 is equals to minus 2. Now we use the formula for angle between two lines when direction ratios are given, that is cos theta equals to A1 B1, A2 B2, C1 C2 upon under root A1 square plus B1 square plus C1 square into under root A2 square plus B2 square plus C2 square. So we write here, if theta is the angle between two lines with direction ratio A1 B1 C1 and direction ratio A2 B2 C2, then this cos theta is equals to A1 A2 B1 B2 C1 C2 upon under root A1 square plus B1 square plus C1 square under root A2 square plus B2 square plus C2 square. Now you can separately find the value of under root A1 square plus B1 square plus C1 square and under root A2 square plus B2 square plus C2 square. So that will be convenient. So we first find the value of under root A1 square plus B1 square plus C1 square. Now value of A1 is minus 1, so minus 1 square is plus 1. Value of B1 is 2, so 2 square is 4. Value of C1 is 1, so 1 square is 1, so we get here square root of 6. Now we find the value of root A2 square plus B2 square plus C2 square. So we write root A2 square plus B2 square plus C2 square equals to, so A2 is 1, so we get 1 square is 1, B2 is 1, so we get 1 square is 1, C2 is minus 2 square is plus 4, so we get square root of 6. Now A1, A2 we find directly here. A1 is minus 1, A2 is 1. Minus 1 into 1, we get minus 1. Then B1, B2. B1 is 2, B2 is 1. So 2 into 1, we get 2. So we write here plus 2. Then C1 is 1, C2 is minus 2. So we write here plus minus. Here C2 is minus 2, C1 is 1. So 1 into minus 2, we write minus 2 upon. We calculate the value of root A1 square, B1 square, C1 square, which is root 6. So we write root 6 into root 6. Now after adding this, plus 2 minus 2 get cancelled. So we get minus 1 in mod. So we write minus 1 upon root 6 into root 6, that is root 6 square. So we write 1 by 6. So taking absolute value, we get 1 by 6. Therefore, cos theta is equal to 1 by 6. Therefore, theta is equal to cos inverse of 1 by 6. So in this way, you can find angle between the two lines.